range of data. Range of the data is the largest value minus the smallest value. Largest value means the largest variate or the largest observation minus the smallest variate or the smallest observation. Suppose data is 2, 3, 4, 1, 0. These are the number of children in different family. So range of this data became the largest value is 4 minus the smallest value is 0. 4 minus 0, that is equal to 4. This 4 became the range of the data. Now types of frequency distribution. There are two types of frequency distribution: inclusive frequency distribution and exclusive frequency distribution. When the upper limit of the first class interval is not the lower limit of the second class interval, that type of frequency distribution is called inclusive frequency distribution. Here you are saying lower limit is 1, upper limit is 5. Lower limit is 6, upper limit is 10. Lower limit is 11, upper limit is 15. Lower limit is 16, upper limit is 20. So what are we saying? This upper limit does not coincide with the lower limit of the second class interval. Means upper limit of the first class interval is not the lower limit of the second class interval. Similarly, here also you can see upper limit of the second class interval is not the lower limit of the third class interval. So this type of frequency distribution is called inclusive frequency distribution. Second is exclusive frequency distribution. In this, upper limit of the first class interval will be the lower limit of the second class interval. Here upper limit of the first class interval is 5, and here 5 is the lower limit of the second class interval. Here 10 is the upper limit of the second class interval. This 10 is the lower limit of the third class interval. So upper limit of the first class interval will coincide with the lower limit of the second class interval. So this type of frequency distribution is called exclusive frequency distribution. Now, in calculation we need exclusive frequency distribution. For that, if inclusive frequency distribution is given, then we will change that inclusive frequency distribution into exclusive frequency distribution. So that I have written here how to change inclusive frequency distribution into exclusive frequency distribution. Rule is we subtract 0.5 from the lower limit and we add 0.5 to the upper limit of inclusive frequency with class intervals of inclusive frequency distribution. As per rule, if you subtract 0.5 from 1, you will get 0.5, and if you add 0.5 to 5, you will get 5.5. Similarly, if you subtract 0.5 from 6, you will get 5.5. So here upper limit was 5.5 and here you are getting lower limit is 5.5. This you will add 0.5, 0.5 will get 10.5. Here you will subtract 0.5, so you will get 10.5. So upper limit of the second class interval became the lower limit of the third class interval. This is the rule that we change inclusive frequency distribution into exclusive frequency distribution. I repeat, by subtracting 0.5 from the lower limit and by adding 0.5 to the upper limit, we change inclusive frequency distribution into exclusive frequency distribution. And our last topic of discussion is class, midpoint, midmark or class mark. All these three words are same. That is equal to lower limit plus upper limit by 2. Lower limit of the first class interval plus upper limit of the second class interval by 2. What will come? That will be the midmark or class mark of the first class interval. I have taken one example. Variables, these are variables, this is class mark. Variables are 0 to 5, 5 to 10, 10 to 15, 15 to 20. I prepared class mark, means 0 plus 5, lower limit plus upper limit. So 0 plus 5 by 2, 5 by 2, and you change in decimal, that will be 2.5. Then class mark of this class interval, 5 plus 10 by 2 means 15 by 2, you will get 7.5. Similarly, 10 plus 15 by 2, 25 by 2, you will get 2.5. 15 plus 20 by 2 means 35 by 2, you will get 17.5. So what I'm saying, if once you find the class mark of the first class interval, other you can find without calculation. Here I got the class mark of the first class interval 2.5. Now difference we are seeing is 5. So I added 5 to get the next one. Here also I added 5 to get the next one. Here also I added 5 to get the next one. But as per formula, the class midpoint or mid mark or class mark equal to lower limit plus upper limit by 2. Let us start exercise 14. Question number 2. Fill in the blanks. Roman number 1. Lower limit of 2633. This is the class interval. In this, which one is the lower limit we are asked? Lower limit lies at left hand side of the class interval. And at left hand side we have 26. So 26 become lower limit. Roman number 2. Upper limit lies at right hand. So upper limit of this class interval is 25. The class mark of 20 and 29. You know class mark equal to lower limit plus upper limit by 2. So 20 plus 29 by 2, 49 by 2, you will divide, you will get 24 by 0.5. If the class marks of a distribution are 32, 39, 46, 53, then width of class interval is next second one minus first one, 39 minus 32, 7. And this will remain, this difference will remain fixed for others also. Third one minus second one, 46 minus 39, 7. 53 minus 46, 7. So this will remain fixed. So class mark of this distribution is 7. Now Roman number 8. If the class mark in a frequency distribution are 19.5, 26.5, 33.5, 40.5, 47.5, 54.5, 61.5, then class size. Class same thing. Class size also second minus first. 26.5 minus 19.5, that you will get 7. And this will also remain the fix. Third one minus second one, you will get 7. Fourth one minus third one, you will get 7. So this will also remain fixed. And remaining questions of this exercise you will get through PDF that I shall make and I will send to the Tenno.